In 10.3, we're going to look a little more closely at some of the features of an ellipse. Okay, this is the standard form of an ellipse. We already wrote this down in 10.0, so you may not want to copy it again. We're going to add a focal radius to the list of information about an ellipse. Focal radius helps us map the foci from the center of the ellipse. The formula for the focal radius is c squared equals a squared minus b squared, where a is the larger radius between the rx and the ry, and then b is the smaller radius. Otherwise, we would get a negative value, which we're not going to have an imaginary root. Okay, so for example, when we're going to transform to standard form, we're going to find and graph the foci as well. Okay, now for standard form, I complete the square, and I also want to have a 1 on this side. Now in this case, this is 8x squared, this is 18y squared. There's nothing to complete, so my only concern is that I get a 1 on the right side. Since there's a 72 here, I'm going to divide by 72. If I do it on the right side, I need to do it everywhere on the left side. Okay, now I got the 1 that I wanted. Okay, but I do want to simplify these first two terms on the left side. I want it to be x squared over something. If I do 72 divided by 8, I get a 9 for the denominator. And then same for this one, I want it to be y squared over something. So if I do 72 divided by 18, I get 4 for my denominator. Okay, now this is standard form for an ellipse. From this, I can tell that the center will be 0, 0. I can tell that the x radius will be the square root of 9, which is 3. And the y radius will be the square root of 4, which is 2. Okay, I'm going to sketch the graph, and then I'm going to go ahead and add the foci to my graph. Okay, let's see, the center is at 0, 0, the x radius is 3, and the y radius is 2. So that's enough for a sketch. Okay, so that's a sketch of my ellipse. Now I'm going to find and graph the foci. The formula from above told me that c squared equals a squared minus b squared, where c is the focal radius. A is the larger of the radii, so between the 3 and the 2, the 3 is larger. So I'm going to do 3 squared minus the smaller radius, which is 2 squared. And again, the main thing to keep in mind is you don't want it to be negative. So for my focal radius, I get the square root of 5. I don't care about the negative answer because the radius is a distance, which must always be positive. Okay, now the foci always occur in the major direction of the ellipse, which is the longer direction. Okay, so the focal radius is square root of 5, which is approximately 2 point something. So from the center, which is 0, 0, in the major direction, I'm going to go to the right 2 point something. So maybe around here, this is one of my foci. I'll call it F1. And then from the center, I'm going to go left 2 point something, so around here, and that's my other foci. It does not matter which one's F1 or F2. Okay, now I'm going to list the coordinates for my two foci, which I sketched. Okay, so from the center 0, 0, I went to the right root 5, which means one of my foci is at positive square root 5, comma 0. The other foci occurs when I started at 0, 0, and I went left root 5. So that will be at negative square root 5, comma 0. For the next example, I'm going to do all the same things. I'm going to change it to standard form. I'm going to graph it and calculate the foci. But in this case, in order to convert it to standard form, I will need to complete the square because there's extra terms. Okay, so if I look at the 25x squared, that's fine, but there's also a 200x here, which means there's going to be completing the square. Same with the 9y squared. If it was just 9y squared, I wouldn't need to complete the square, but because of the 18y, I do. So first thing I'm going to do is group the x squared terms together. So I have 25x squared minus 200x. I'm going to put those together. Okay, then I'm going to group the y terms together. So the positive 9y squared and the positive 18y. I'm actually going to cancel the plus 184 by minusing it to the other side so I can get it out of the way. Okay, now before I complete the square, I need to factor out the coefficient in front of the squared term. Okay, so for the 25x squared, I'm going to factor out a 25 minus. Make sure you factor the 25 out of the 200 as well. So 200 divided by 25 takes me down to 8x. And then I'm going to complete the square, but I'm going to come back to it in a second. Okay, I'm going to factor for the 9y squared, I'm going to factor out the 9. And I'll have y squared plus, make sure you factor the 9 out of the 18. So that will be 2y. I'm going to leave it blank because I am going to complete the square in a moment. Okay, now I can complete the square because this leads with an x squared term. So half of -8 is -4. -4 squared is 16. So to complete the square, I'm going to add 16 here. To complete the square on y squared plus 2y, half of 2y is 1. 1 squared is 1. So to complete the square, I add 1. Now to balance out the equation, I need to add the same amount to the right side, but I need to do so carefully. I added 16 here, but 16 is in these parentheses, which 25 gets distributed to. So even though I added 16, I really added 25 times 16 because the 16 is inside the parentheses and the 25 is going to be distributed. Okay, and then I added 1 here to complete the square, but again, the 1 is in parentheses with a 9 on the outside. So when I distribute the 9 times 1 means I'm actually adding 9 to the right side to balance it out. Okay, let me see what I have left. Okay, I'm going to keep the 25. I can now factor this into a perfect square. The y squared plus 2y plus 1 also factors. Okay, and then I'm going to add up the right side. I end up with 225. Okay, so this is looking good in terms of the center of the ellipse and the completing of the square. Now I just need to make sure that I get a 1 on the right side so it can be in standard form. So I'm going to divide by 225. Okay, and remember, I want the x minus 4 squared by itself. I want to have a denominator because the denominator tells me what the x radius is in this case. So 225 divided by 25 makes this a 9. If I do 225 divided by 9, I get 25, and then 225 divided by 225 is 1. Okay, so now I'm in standard form. Now I can get all the information I wanted. Okay, so the center is 4, -1. The x radius is 3, the y radius is 5, and that's enough information to get a decent graph. If you have graph paper, you will have a better graph than me. Okay, what is my x radius? 3, so I'm going to make this go 3. Y radius is 5. Y is 1, 2, 3, 4, 5. Okay, this is a good, decent sketch of my ellipse. Okay, now the only thing I'm going to need to calculate is the focal radius so I can graph the foci and write the coordinates of it as well. Okay, if you recall, the formula is c squared equals a squared minus b squared, where a is the larger radius. So between the 3 and the 5, the larger radius is 5. The smaller radius is 3. Okay, so the focal radius is going to be 4. Okay, now the foci lie along the major axis, which is the longer direction. So because this is taller in the y direction, the foci will lie 4 units from the center of the ellipse in the y direction. Okay, so let me think, because I don't have graph paper. And you probably won't either. Okay, so if I want to graph the first foci, Let's see, let's say I start here and I go up 4 units. 1, 2, 3, 4. I end up around here. And as long as you end up inside the ellipse, it's a good side. Okay, what would be the coordinates of that? I'm going to list it over here because I don't have room. Okay, I started at 4, -1. I went up 4 units. So from -1 up 4 units, I ended up at 4, 3, which makes sense with my picture. Okay, now from 4, -1, I'm going to go down 4 units. 1, 2, 3, 4. I end up inside the ellipse, which is good. Okay, I don't have room to label it here, so I'm going to label it over here. So from 4, -1, I went down 4 units. So -1 down 4 units is going to take me down to -5, which looks consistent with my graph, so that is probably correct. Okay, the last thing we're going to do is combine what we did in a previous chapter with what we're doing in this chapter. So we're going to find the intersection of these two conic sections algebraically, and I'm going to graph to confirm the results. So we're going to solve the system, and I'm going to graph it so we can confirm that we actually did it correct. Now, if I look at these two equations, I could do elimination, I could do substitution. Which way am I going to do? I think I'll do elimination. Okay, if you do substitution, I'll show you how I would do that as well. I'm going to cancel the x squareds out. I don't want to do the y squareds because then I'm still going to have this extra y over here, which is no good. So I'm going to multiply the first equation by -5. Okay, the x squareds cancel. I get 3y squared. Okay, let me put this in standard form. Okay, and then I'll add the 125 over to the left side. Okay, now I think that I can factor out a 3. You could have also divided by 3 on both sides because the 3 doesn't have a variable, so it doesn't affect the solutions. Okay, what do I multiply to get 39? 13 times 3? Okay, so I get y is 13 and y is 3. I'm going to substitute that back in to find the x's. If you wanted to do substitution, I would solve for x squared. So x squared would equal to 25 minus y squared. And then I would make the substitution right here, and I would have to distribute, and I would get the same answer. Okay, now I can plug the y into either of these equations. The first equation looks significantly easier to me, so I'm going to go ahead and plug it into that one. Let's see which one. If I plug in y equals 13, okay, I'm about to get an imaginary number, huh? Okay, so the y equals 13 is actually not a valid y value, even though I did all my work correctly. Let's check if the 3 is x squared plus 3 squared equals 25. Okay, so according to my calculations, 4, 3 and -4, 3 are the two solutions for this system. Okay, but now that we know how to graph them, I'm going to graph them to make sure that that is in fact where they intersect. I'm going to rewrite the equations below, I think. Okay, so these are my original equations. I'm going to go ahead and graph it. Now the first equation is a circle. I can see that the center is 0, 0, 0, and the radius is 5. So I'm going to go ahead and try to get that one graphed. And even though it's a sketch, I want it to be kind of decent so that I can tell that my intersection points are reasonable. Okay, now the second graph is an ellipse. I can tell because it's 5x squared plus 8y squared. They have different coefficients on the x squared and y squared. terms, although they are both positive. It is not in standard form, so I'm going to have to convert it. Okay, the 5x squared, I'll leave alone. The 8y squared, I'm going to group it together, and then I'm going to move the minus 8 to the other side. 5x squared is going to keep hanging out, but the y squared, I need to factor out the 8, and then I need to complete this square here. So half of 6 is 3, 3 squared is 9. Okay, then when I add it to the other side, don't forget I need to add 9 to balance it, but it's really 8 times 9, which is 72. '72 plus 8, 80. Okay, this is pretty close, but I do want there to be a 1 on the right side because it's a ellipse. Okay, let me try to graph this one now and make sure that my answers I got algebraically seem reasonable. So the center is 0, 3, which is up here. Okay, the x radius is 4. Okay, 1, 2, 3. So around here. 1, 2, 3, 4. Okay, the y radius is the square root of 10. The square root of 10 is 3 point something. So 1, 2, 3 point something-ish. And then up here, 1, 2, 3 point something-ish. Let me make my graph a little teeny bit bigger. Okay, and then I'm going to go ahead and sketch my graph. Ooh, that looks a little dorked, but that's okay. Okay, now let me check above what my previous answers were. So I had 4, 3 and negative 4, 3. So if it does seem reasonable that this is 4, 3, it's also reasonable that this would be negative 4, 3. And it does make sense that the y equals 13 got discarded because that's too big, too high to be included on either of these graphs.